Hello everyone, I hope you all are doing well. This side Priya Bhatia, and in this specific video we will be discussing about one of the most important concept in DSA. I think you can guess it. It's a recursion, right? If you will talk about divide and conquer algorithms, if you will talk about dynamic programming, if you can see each and everything, at least the modules in algorithms which are very important in terms of interviews perspective or in terms of solving complex interview questions, I would say recursion plays somehow a very important role. So in this specific video we will be discussing about recursion in a very detail, and you will observe that this is a recording of one of my paid course, and in this specific course I'm also teaching to the learners about the interview questions, the mindset with which you have to solve any question with respect to recursion. Try to be very attentive in this session because this will be a quite longer session, requires a lot of patience from your side. But one thing which I can make sure that if you will watch this session till the very end, definitely you will get a lot of insightful content out of it, and you will be able to get an idea first of all what is recursion all about, what is the difference between iterative approach versus recursive approach, how basically whenever we are solving any question, what is the mindset actually we have to take care of in order to solve any question with the help of recursion concept. And there is one issue in recursion solution also, and that is where the origin of dynamic programming came into picture. So everything I'm discussing in this session in a lot more detail. So I hope that you all are excited to learn all of these things. But please make sure before coming to the next part of the session, you will share these videos with each and everyone. Your support really means a lot to me. Subscribe to my channel, and definitely if you will just keep on supporting me, definitely we will reach very soon to more wider audience as expected. So with this, let's get started. The recursion is nothing but when a function is calling itself in the function definition, right? After that, we have talked about the problems with respect to recursion, where the very first example which we have picked up is the factorial of a given number. We have seen that for every recursive code, a stack space is required in order to store the function calls. Apart from that, we have seen that for every recursive code, we usually require two important things to take care of. What are those? One is the
Base condition.
One is the base case condition, which basically helps us to stop the code, right? That is the stopping point. Second thing is the
Recursive function call.
recursive function call. So for every recursive application, whatever problems today we will discuss, the complete discussion is all around the recursion today, right? And after that, I will give you more problems with respect to interviews after this class, which I really want you all to solve at your own, okay? So we will practice a lot many interview problems in today's class with respect to this recursion part. Apart from this, I have talked about with respect to factorial that for every recursive code, we usually try to create a recurrence relation in order to find out the time and space complexity. Specifically, time complexity, space is something which is definitely is required because we are using a stack space, which is an external data structure, right? After that, we have seen that, in order to solve any recurrence relation, there are three important methods that we have. What are those?
Substitution method, recursive
Substitution,
tree, and recursive tree, and then
recursive tree,
master's theorem.
Master's theorem. So basically, we have three methods to solve any recurrence relation. And whenever we are talking about recursion, usually we have two approaches. Usually we have two important approaches, two important ways to implement any logic. One is something which we call as iterative approach. Iterative approach. And second way of doing an implementation or writing a logic is the recursive approach that we have discussed in our last class. And always remember one more important thing. I think I didn't talk about this thing, that for every recursive code, for every recursive approach, a point to note here that always remember that for every recursive approach that we have, there exists a iterative solution as well. For every recursive approach, there exists an iterative solution as well. What is the meaning of iterative solution? I hope recursive solution everyone knows. What is the meaning of iterative solution? Means you
Loops.
are using loops.
Using loops.
Yes. Means you are using either for loop or while loop in Python to implement a code. So if you remember, when we were talking about the time complexity aspect, if you remember, there we have discussed that in an iterative approach, if our code exists, the loops are nothing but represents a time complexity. Higher the loops, higher the complexity. If let's say we will be having 2 nested loop, complexity will become big O of n square. If we have 3 nested loops, it will be big O of n cube. But now we are moving ahead towards our discussion with respect to the recursive approach. And that's where I told you that first of all, we need to create a recurrence relation. And once you will be able to create a recurrence relation, then you need to find out with the help of either substitution method or recursive tree method or Master's theorem, that what will be the time complexity. So it's very easy to find out in the iterative approach, but here we require some extra effort in order to compute the final time complexity part. With respect to space part, it's pretty much clear that for every recursive approach, we required extra space, which is a stack space. Depending upon how many levels of stack space we are using, it really depends on that part. What is the, space complexity for that particular code? So let's start our discussion from that part now, right? If you remember, at the very end, we have discussed about a substitution method, and I hope that is very much clear to everyone. We have solved our code of a factorial, where we have solved a recurrence relation T of n is equals to, I think, T of n minus 1 plus C. And what we have observed, that the time complexity of this recurrence relation is big O of n. It's linear, right? This is the last class discussion that we have done for a factorial part. After that, I talked about another application, which is a Fibonacci series. And that's where we have discussed that Fibonacci series is nothing but is the addition of the previous 2 numbers. And we have discussed that, let's say, we will be having this kind of a list or an array, right? Where we will be having indexes 0, 1, 2, 3, 4, 5, 6, and 7. So here we will be having 8 number of elements. What is the value when the value of n is 0? What is the Fibonacci number? Let's say Fib
0.
array. So what is the value here? It will be
0.
1.
0 or 1. When the value
1.
of n is 0.
It will be
0.
1.
It's 1. For 0 and 1, it's 1.
Someone is saying, okay, some people are saying 0. Some people are saying 1. Any other student who is saying any other number? Infinite, something like that?
Okay, sorry. Whether I can write. For 0,
So how this Fibonacci number concept came into picture? Anyone is having any idea? What this series says?
Sum of the previous 2 integers. Sum of the previous 2
Basically, it
values.
says the addition of the previous 2 integers. Okay. So you will observe that when you are typing the value of fib of 0, it will be 0. When you are saying fib of 1, it will be 1. Moving ahead, when you're moving towards 2, it will be the addition of the previous 2 numbers, which is 1, 2, 3, 5, 8, 13. This is how the series will work. So what I have done, again, I am repeating. If I'll say, what is the base case condition? The base case condition will be when the value of n is less than equals to 1. If this is the case, then what we will do? We will simply return the answer as
N value.
n, right? When it is 0, 0. When it is 1, 1. Otherwise, we are saying in else case, return the answer as fib of n minus 1 plus fib of n minus 2. And that's where in the last session, I have explained you with the example of fib of 5 that how this answer of 5 is coming up. We have created a complete recursive tree, and we have seen that there exists one problem also in that recursive tree. What was that problem named as?
Even though the function is evaluated, but still again we need to re-evaluate it.
Yes. So
And
what
you
was
said
that phenomena called as?
Overlapping subproblems.
Very good. So we have observed that there exists a problem of overlapping subproblems. Means similar subproblems are there, similar function calls are repeating. And what this recursion is doing is, this recursion is doing a recomputation of similar function calls. And that is the major reason that, the time complexity of this particular code is very, very high. And I told you that was nothing but is 2 to the power n, which is nothing but is called as exponential time complexity. Exponential time complexity. Right? This is the thing which we have covered up in our last class. So this is the part of a Fibonacci series. Today, first of all, we need to understand that how is this coming up directly. I have written it down as exponential, but let's try to understand that how is this exponential is coming up. And then step by step, we will move ahead in the session. So if I'll ask you that, again, here if we will observe, this is something which is the first component of our recursion part, which is the base case condition, right? And let's say our function name is fib of n. So this is something that we can call it as a recursive function call. Second component of recursion is recursive function call, right? Perfect. Now, this is fine. If you will be able to observe, if I'll talk about it, what is the recurrence relation for the same? Prajwal is asking one question. Is this exponential? Yes, this is exponential only. This is what you have done, right? Yes, you have divided your components of base part into 2 parts. When n is 0, you are returning 0. When n is 1, you're returning 1. Again, it's a constant thing, right? After that, in the else part, you are again calling this fib of n minus 1 and fib of n minus 2. Perfect. This is where you're calling the same function again. Same function again. This is what we call as recursion. Now, today, let's try to understand why this is exponential. What's the reason behind that? So before talking about that, first of all, we need to create the recurrence relation for the same. So let me know what is the recurrence relation of this part. I think this also I have mentioned in the last class. What we are saying that when the value of n is less than equals to 1, at that point of time, it's a constant task, right? It's a constant task. But when the value of n is bigger than 1, in that case, we are using the concept of recursion. So let's say our function time complexity is t of n. So we are saying t of n minus 1 plus t of n minus 2 plus c. For the addition part, there is a constant thing which is required, right? This is the recurrence relation that we have. Now, always remember, first method I think I already have discussed, where we are doing a substitution of every recursive term. That's why it's called as a substitution method. Second method today we are discussing, which is the recursive tree method. This method says that whenever you will be having more than one recursive term, first of all, how you will get to know that it's a recursive term? This t is repeating, right? T is repeating, t is repeating. So it is indicating that it's a recursive term. And always remember, whenever we will be having more than one recursive term in a recurrence relation, recursive term in a recurrence relation, in that case, we always go for only single approach that we have, which is a recursive tree method. Recursive tree method, right? So let's try to solve this particular problem via recursive tree method. Please try to understand that how basically this recursive tree approach will work, okay? So हम क्या कर रहे हैं? What we are doing here is we are saying that we are dividing our n complete array list that we have into two components, n minus 1 and n minus 2, right? And then we are doing addition of that. That effort required to the addition is a constant task. A cost is required to do this particular task of splitting our data into n minus 1 and n minus 2 is C. Further again, when you will move ahead with respect to the next recursive call, what you will do? You will again split this n minus 1 into two components. What was that? It will be
n minus 2 and n minus 3.
n minus 2 and n minus 3. And again, the effort required or the cost required to split the value of n minus 1 into n minus 2 and n minus 3 is constant. Can I say C? Similarly, you will do the same task on the right side also. It will be n minus 3 and n minus 4. Again, it will be C. So for the second level, total cost required is
2C.
2 into C. Can I say everyone? It will be 2 into C. Similarly, you will do the same performance task in this part also. Yes or no? It will be n minus 3, n minus 4, n minus 4, n minus 5, n minus 4, n minus 5, n minus 5, n minus 6. Similarly, these things are again a constant quantity, C. So if I just add all these levels, the total cost will become in this level is 2 ki power 2 into C, which is 4C. Similarly, if you will see in the below level, again, if you will do the same task, you will observe that in the next level, you will be able to get this number as 2 ki power 3 into C, and so on. This process will keep on going. Initially, it is 2 ki power 0 into C, 2 ki power 1 into C, 2 ki power 1 into C, 2, 3, and so on. This is what we call as a recursive tree, right? Recursive tree, where the recursion is happening, means similar things keep on rotating here. N split into n minus 1 and n minus 2. N minus 1 is n minus 2, n minus 3. Here also, same things are happening, right? So far, so good. Does everyone agrees with me until this part? Any doubt, anyone? How the C is coming up? Just refer this thing. What is the extra cost required to split our data n as n minus 1 and n minus 2? This is mentioned here. It's C. So far, so good. Shall we move ahead?
Priya, is it for the addition also, right? Like these two terms we are adding, the n minus 1, n minus 2. So for that, right?
Yes, yes, correct. Okay, perfect. If there is no confusion, let's move ahead. Usually people get confused on this point. That's why I take a pause. Now, what we have to do here? We need to calculate the total time required to complete this task, to get that value, right? Total effort required. So what we're supposed to do is we're supposed to add all these values for all the levels. So what will happen? You need to compute the number of levels, then only you will be able to add. For example, this is the 0th level, it is 2 ki power 0 into C. First level, it is 2 ki power 1 into C. Second level, it is 2 ki power 2 into C. So what is happening? If I take C as common, my total time complexity T of n is equal to C, which is the common thing I have extracted outside, 2 ki power 0, 2 ki power 1, 2 ki power 2, until let's say we will be having in a complete recursive tree, k number of levels, it will be 2 ki power k. Now the question is, we need to compute this level. We need to compute what is the number of levels we have in this particular recursive tree. That is the task which we have to perform. So Now the question is how we will be able to get an idea that how many number of levels we have in this recursive tree. Let's try to understand this part. On the left side, if you will be able to observe, what is happening? You are keep on subtracting your data with -1. Can I say everyone? You are doing n-1 only, n, n-1, n-2, n-3. So for the kth level, you will be able to get, can I say n-k on the left part, on the left side, left root node, will you be able to get this answer, n-k, at the kth level? And at what point of time I will stop my code? I will stop my recursive tree. When I will reach to a base case condition. What is the base case condition? When my value of number of data points, when the value of n is either 0 or 1. Do you remember the base case condition? You said to me that when the value of n is 0, answer is 0. When the value of n is 1, answer is 1. It's a constant task, right? So when the value of this particular level will become either 0 or 1, at that point of time, I will stop my code. You can take any one value. You can take a 0 also, you can take a 1 also. It doesn't matter. It will not affect our answer. As of now, let's consider it as 0 because it's a base case condition. When the value of n is 0, my answer will be 0. So what is the value of k you will be able to get here? It will be n. On the right side, if you will generalize the statement, if I'll ask you what you are trying to do in the right side, start going from the start, n, n-2, n-2, n-4, n-4, n-6, n-1, n-3, n-3, n-5, n-2, n-4. So what are you doing in the right side? This is the right side. This is the right side for this case. So what you are trying to do in the right side?
n-2k.
Can I say this approximately? This is what we are doing. At the kth level, what is the generalized statement which you will be able to give me?
n-k-2.
Okay, now you might get confused between these two things. One thing is this thing. One might be this thing, this one. Someone just now said n minus k minus 2. Try to observe. Let's say here we will be having number of level is 2. N minus, so n minus 1 minus 2 minus 2. So it's not correct. N minus k minus 2 is not correct, right? So if you will write the statement of n minus k minus 2, 3 will not come. The more generalized statement would be if you can say it might not be the approximate one. It's kind of generalization we are doing, which is equally valid for all the equations. So can I write it like this? Approximately we're getting something like this, n minus 2k, which is equals to again 0. Approximately we are trying to subtract in the right side by minus 2, minus 2, minus 2, minus 2. When the value of k is 1, it will be n minus 2, 2, n minus 4, n minus 6, n minus 8, and so on, depending upon what is the value of n you have. So again, the value of k will come here as n by 2. But the question is, which one is the bigger level? That is where we have to focus, because we are here computing our worst case time complexity. So left side level is bigger, right side level is bigger.
Left side.
Left side.
Left side.
Left side.
So if we will be able to cover up the complexity of a left side, automatically right side will be covered up, right? It's not a symmetric tree. So right side will be having almost half the number of levels. I'm saying almost. Exactly, we are not sure, but approximately half the number of levels are available in the right side as compared to the left side. So I will focus on the value of k as n. So what I will do here, I'll replace the value of k with n in this equation. Now, solve this equation. This is nothing but is a GP series. Can I say everyone? What is the meaning of GP series?
Geometric progression.
Geometric
Geometric
progression.
progression where the common ratio will remain the same. How you will be able to figure out it's a GP series? Always check it out. What is the common ratio? Now, these things you must have seen in your, again, lower mathematics classes. 11th, 10th, 11th, 12th. What is the common ratio? 2 power 1 divided by 2 power 0. It's R is equals to 2. Sum of GP series is
A into R to the power of n minus 1 by R minus 1.
A into
R to
R
the power
power
of n
minus 1
by
divided by R minus 1. Very
because
good.
R is greater than 1.
Yes, where R is greater than 0. When the R is less than 0, it will be opposite. 1 minus R power n divided by 1 minus R. If you want, you can just check it out, these formulas. But yeah, this is the thing that we have. So if you apply this formula, A is nothing but is the first term in our GP series. R is the common ratio, N is the number of values we have. So let's try to apply this formula. C will remain the same. R is 2 power n minus 1 divided by 1 itself. So if you will multiply, you will be able to get C into 2 ki power n minus C. Nothing but is equals to big O of 2 ki power n, because remaining things are constant only. We are working on approximation. So it is nothing but will come out to be a exponential time complexity. And if you will remember from my, I think in the second class itself, I have discussed the complexity classes. Just refer that lecture notes. You will observe that this is one of the very high complexity among all the complexities that we have discussed so far. Very, very big. And the major reason behind this high complexity is, I already have discussed, that is the major issue. And that's why you will observe that in order to avoid this problem, we have a separate algorithm which we will discuss in our future classes called as dynamic programming. Dynamic programming. That we will discuss in a later part, but I hope it is clear to everyone.
Priya,
That
can
what's
you
the
just
reason?
say, yeah, can you just go ahead, like again explain the left and right part which you have taken?
Okay. So here, if you will be able to observe, we need to find out the number of levels. Like this is a tree. Until so far, I will keep on doing a subtraction by -1 on the left side and -2 on the right side. I have to somehow stop after some point of time. So basically, we have assumed that in order to compute the total number of values, cost requirement, we have added everything. But now I'll keep on moving this until the k number of levels, considering that we will be having in a recursive tree how many levels? K levels. Now the question is, what is the value of k? How many number of levels I have in this recursive tree? How will I compute? So basically what we have done is we have tried to add all these values. See, we have taken outside this k. How we can compute? We are just checking on the left side, we are doing -1, -1, -1. So this equation, when we will be having at the very last level, we will be having the answer as n minus k. How will it be equal to 0? Because you need to think now, at what point of time I will stop my code? What is my base case condition? At which point of time my code will get stopped? So I know that when the value of n is either 0 or 1, my code will be stopped. That's the base case condition, right? So basically, it means that either you can take the value as 0 or you can take the value as 1, because that is your base case condition. And then you can try to compute the value of k on the left side. This is the number of levels on the left part, But you need to do the same thing on the right side also. So basically, right side, what you are doing, you are trying to do a subtraction by -2, -2, -2, -2. So it will be n minus 2k, which is again equal to 0. So here again, you will try to compute the value of k, which is approximately half the number of levels on the right side is approximately half the number of levels available on the left side. That is what we have computed. So by referring this particular scenario, we have observed that left side has higher number of levels. So when I am computing my time complexity, I need to cover up all the cases. Worst case part I am assuming. So it means I will take a bigger level so that my smaller level will automatically get covered up. So what I have done is I have substitute the value of k as n, and then I had tried to solve my equation to get the overall time complexity. Is this clear now?
Yes.
Anyone, any other doubt? Shall I give you guys one problem? You will try to solve via recursive tree approach. It is a bit complicated, but if you will just do 1 to 3 problems now, it will be okay for you all. It's not that much difficult. It seems like if you will do one problem more, I think if you will be able to get the correct answer, it means you will be able to understand what I'm trying to convey here. So I'm giving you one problem. Try to solve it just in the session itself. As soon as possible, you can do it. And then we will move ahead to the next important part of the session. Let's say you will be having the value of t of n as t of n by 5 plus t of 4n by 5 plus n. Okay? This is the equation. And the best case scenario will be when the value of n is 1. Consider when the value of n is 1, my value is equals to 1. My t of 1 is equals to 1. This is the best case scenario, let's assume. Okay? When the value of n is bigger than 1, this is the recurrence relation. Now again, if you will be able to observe, we have more than one recursive term. This is first one, this is second one. That's why the only method which will work here is recursive tree approach. So solve this problem. Do it. Now, let me just give you an initiation part and then you can move ahead. What we're trying to do here, we are saying n will be split into two components here recursively. One is left side n by 5, right side 4n by 5. And the effort required to just do the split and then do the addition is something which is written as n. It's not constant. It is now n. So this is n. Do the same thing again. When I'm splitting my data of n into two components, n by 5 and 4n by 5, the effort required is n. When you will do this further split of n by 5, on the left side, observe what you are doing. You are doing a division by 1 by 5. So multiplication by 1 by 5, division by 5. On the right side, you are doing a multiplication of 4 by 5. So do the same thing. What your equation will look like, it will be n by 5 ki power 2. It will be 4n by 5 ki power 2. What is the effort required to do so? It will be n by 5 in this case, not n. Because when you're doing split of n, it is n. When you're doing a split of n by 5, it will be n by 5. Don't do this mistake. That is the only thing which you have to make sure. So if you will do the further split of this 4n by 5, what you will be able to get? Think over it. What will be the cost? And then calculate the total cost. Left side plus right side. That's what I have written. If the value of n is 1, answer will be 1. It's a constant task. Very good. The next level on the right side will be, can I say it will be 4n by 5 square and 4 square n by 5 square, right? The effort required to split 4n by 5 is again 4n by 5. Because when I'm doing a split of n, it is n. n by 5, n by 5. 4n by 5, 4n by 5. Total cost or effort required in the second level will be add n by 5 plus 4n by 5. It will be equals to, can I say n only? Will you guys agree with me?
Yes.
Now, again, when we do the further split, what will happen? N by 5 ki power 3, 4n by 5 ki power 3. And so on. You can do this. And you will observe, it will be n by 5 square only. It will also be same. It will also be same. It will also be same. So it will again be addition of all these things will be n. So what you're observing here is that every level, your cost will remain the same now. It is n only. But the question is how many number of levels we have to compute the total cost. Let's say it is k. So now we need to figure out what is the value of k. Again, split into two parts, left side and right side. Now let me know on the left side what you are trying to do. You are trying to do division by 5 by 5 by 5 by 5. When you are at the first level, it will be n by 5 ki power 0, 5 ki power 1, 5 ki power 2, 5 ki power 3. So when you are at the kth level, on the left side, what value you will be able to get?
N by 5 to the power of k.
Very good. N by 5 to the power of k. And what is the best case condition? It is equal to which value?
Yeah.
1.
1.
1. Right? Solve this equation. N is equals to 5 ki power k. What is the value of k? Take log
Log
base 5, both sides. K will come ahead. Log 5 base 5 will become 1. So can I say the value of k will be log of n base 5 in this case on the left part? What will be the value of right side equation? Can I
4
write like this? N by 5 by 4 ki power k. What I have done is, it's 4n by 5, right? Take 4 below to generalize the equation. So it will be 5 by 4 to the power k, which is equals to 1. So can I say here the value of k will come out to be log of n base 5 by 4? Think over it. I have directly written it down, but it's one and the same way to compute this as well. Here we will be having 5, so base is 5. Here we will be having 5 by 4, so base is 5 by 4. Which level is bigger? Which value is bigger out of these two?
Log 5 base n.
The right
Log n base 5.
Log n base 5.
Left side or right side?
Right side.
Left side.
Okay.
Left
There are
side.
two teams.
Left side only. Left side.
Which
only.
Left side. Left side. Left side.
Left side.
Higher the base, lower the value. Which base is higher?
Right side base. Oh.
Which
Left
base
side
is
base
higher?
is
Left
higher.
side base is higher.
Yes. It means left side value is lower. Right? Right side is bigger. I have written so many times this line. Higher the base in logarithmic, lower the value. Remember this thing. So it means right side is bigger, right? Right side value is bigger. Right side value is bigger. So what you will do? Your time complexity will become big O of number of levels into n. Now you will ask me one question. So let me write it down first. Log of n base 5 by 4. So it will be, I would say, n into log of n. What I have done here, let me try to explain. For every level here, we will be having same value. It is n, it is n, it is n. We want to add all these values until k levels, right? So what is the total complexity? Can I say it will be n into k for all the levels? I will give you a simple mathematical problem here. Let's say in my class, I have 5 students. And I want to give every student 2 chocolates. So how many chocolates should I have? I want to give every student of my class, every student I want to give 2 chocolates. So how many chocolates I should have? It will be 10. How you computed this? One way can be, you can say 2 plus 2 plus 2 plus 2 plus 2. you will reach the same answer. Another way you will say, what I have done is, I have done the things smartly. I have said 2 into 5 will come out to be 10. But let's say this is a case number 1. Case number 2, I am saying that let's say I will be having again 5 students in my class. And the first student I am giving 1 chocolate, then 2, then 3, then 4, then 5. Or it can be any other number also. Let's say the last student I am giving 6 chocolates. So in this case, you need to add manually, right? Every number. So this case number 2 belongs to our first example, where we have done the manual addition. Because for every level, we have some different value. So we have added it manually. But this case number 1 belongs to this example, where for every level, we have same cost, which is n. We have k levels. So we just did the multiplication of n into k to get the final answer, to get the final complexity. Is it clear now? Is this clear? How we usually compute the complexity? Basically, we are doing the same thing, addition of all the cost values in all the levels that we have. But here we did it directly. In the above case, because the values are different, we did the addition. Form the GP series, solve that mathematically. Yes. Is the recursive tree approach is clear now? Any doubt? In the lead code also, I have given you one question, two questions. One is climbing stairs, one is Fibonacci series. Have you tried these 2 problems at your home?
Yes.
Did you guys got the answer correctly?
Yes.
Both the approaches? Both the problems works fine for you?
I have tried for the Fibonacci and it worked.
Okay.
Yes, I have also tried for Fibonacci.
Okay. So if you will be able to observe, in the platform, I have also uploaded new problems. Have you guys checked that? Have you guys checked that?
Yeah.
Let me just show you. So here I have attached 2 problems. One is with respect to the climbing stairs. Another one is with respect to the Fibonacci. So there is only one student who have mentioned this, but I was expecting from everyone. If you will try to solve this problem of climbing a staircase, you will face this error. TLE, time limit exceeded. And I have talked about this in the last class also. What is the reason behind that? Because if you will be able to observe, the constraint, the range of value is very, very high. It was approximately moving ahead towards 45. That's the major reason. So we will take this problem of climbing stairs again, and we'll try to solve at the time when we are solving a DP, dynamic programming. And we will try to avoid this problem of TLE at that point of time. Okay. Let's move ahead to the next important part. So there is no need to do the implementation of Fibonacci series. Shall we move ahead? Does everyone, is agree with me with respect to this part? Will you guys be able to solve these problems? Or do you want me to do the implementation for the same? I think it's very easy, right?
Yes.
Okay. Let's move ahead and try to solve one more problem, which is very widely again asked in many interviews. The problem says that, let's say you will be having a number. Interview will provide you some number. Let's say the number is 1, 2, 3, 4, and 5. What I'm looking for is, I'm looking for a sum of digits of this number. I'm looking for sum of digits of this number, which is 1 plus 2 plus 3 plus 4 plus 5. Basically, it will be 3 plus 3, 6 plus 4, 10, 15. This is the problem number, I think, variety of the problem 2 in the recursion. How can we solve this problem?
So
So we
we
can take a modulo of 10 and then we just add it to a number. We just add it. So we first initialize a variable to 0, and then we perform the modulo 10 operation, and then we just loop it until the num is equal to 0.
Okay, we want to solve it via the concept of recursion.
so in recursion, the base case would be if the division of a number gives 0. And what we'll do is we'll take the modulo, obviously, and add it to the counter variable. And then we'll call the recursion on the same number by 10, basically, like
Okay,
say sum of
perfect.
digits n by 10.
Can you guys try to do the implementation for the same? And then, so basically, let me first of all explain what he has said, and then let me give you that as a live code demonstration. So what we can do here is, if you guys will be able to understand, first of all, when I'm saying recursion, first of all, think about the base case condition. What can be the possible base case condition we can have? Simple, you can say that one simple thing which you can say, for example, let's say I will pass a number as 9. In that case, what is the sum of digit? What is the sum of digit? SOD. It is equals to
It's 9.
9.
9. Can I say when the number is less than 10? When that number is less than 10, in that case, what I will return? The answer is
That number only.
that number itself. Can I say everyone? Is this correct? Let's say sum of digit, and here I am passing the parameter as number. If this condition is true, I will return directly. Does everyone agrees with me on this note? If that is not the case, in else part, what will I return? I will say take number modulus 10. Now what this modulus will do? This will give me the remainder, or this will give me the digit. Can I say everyone? Plus, so basically what will happen? Let's say we have a number 1, 2, 3, 4, 5. For the very first time when you will do the modulus by 10, what value you will be able to get?
5.
What is the value of 1, 2, 3, 4, 5 modulus 10?
5.
5.
Should be 5.
5 plus. Now, I want to focus on the remaining digits. How will I able to get this 1, 2, 3, 4? Can I say what
The
I will do
num by
is?
10.
Integer division.
Yes, I will say sum of digit. I'll call this function again. That's where recursion will come. Whatever your number, do the division by 10. So when you do the division by 10, so what will happen? You will call the same function and you will be able to get the now the parameter as 1, 2, 3, 4. Then you will apply the same analogy again. You will say it is not less than 10. So now my current value will become 4 plus sum of digit of 1, 2, 3. Then again, you will apply the same thing here. 3 plus sum of digit of 1, 2. Then same thing. 2 plus sum of digit of 1. Then same thing. But here we will be having a single digit which is less than 9. It will return the answer as 1. So 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 5 is 15. And our answer will be returned. And all these function calls, by the way, will be stored in a stack-based data structure. So what will happen? Sum of digit, you will start with a 1, 2, 3, 4, 5. Then you are calling sum of digit 1, 2, 3, 4. Then you are calling sum of digit 1, 2, 3. Then you are calling sum of digit 1, 2. Sum of digit 1. Yes, this is the correct code. So this is what? Let me copy this down and paste it. Okay. So the first problem, not the first problem, problem number 2, we can say, of today's session is sum of digits, right? So I'm just copying it down. This is the code written by Yashasvi. Even Pawan has also written, it's correct. So basically, let me just fill it firstly. Let's say we will be having a driver code. And in this, we will be having a number which is equals to 1, 2, 3, 4, 5, right? So what we can do is we can say result, which is equals to sum of digit. And here we can pass the number. And what we can do is simply we can print this result. Number, if the number is less than 10, in that case, we're returning directly the number. This is the base case condition. Two components. One is the base case condition. This is what we have as the base case condition. Second component is what we have is the recursive function call. So we're getting the answer as 15, correct? Now, if I'll ask you, what is the time and the space complexity for this code? What is the time and space complexity? Someone said constant. Is that so? What is
Space
the
is
time
constant.
complexity?
Space complexity is O of n.
And what is the space complexity? Okay, let's first of all discuss the space part. Someone said constant and someone said big O of n.
It's
Think
big
over
O
it
of n.
again. It will be big O of n. Why is that
N.
so? Because here, if you will be able to observe, we have started with 1, 2, 3, 4, 5, right? We will be having 5 digits here and 1, 2, 3, 4, 5. 5 levels of space we are using in the stack also. So basically, because we are using here an external data structure, which is a stack space, in order to store the function calls, So in this case, it will be big O of n. Now let's talk about the time complexity. What do you think? Now, in order to compute the time complexity, you need to compute, first of all, what is the recurrence relation again. Once you will be able to find out the recurrence relation, then only you can solve that recurrence relation and you can let me know what is the complexity by solving it via either substitution or recursive tree. Until so far, we have covered up 2 methods only. So what do you think?
Substitution.
What's the recurrence relation? First of all, let's talk about that.
If n
N
is less than 10,
If
then
n is less
constant.
than 10, in that case, it would be constant. Okay,
Constant,
C.
yeah.
If let's bigger than 10, then what we can do?
N mod 10, then plus.
I think it's n by 10 or no. Yeah. Because number of digits, right?
This n indicates the
Of n
number of
minus 1.
digits. This
T of
n
n
indicates the
minus
number of digits.
T of
Even
n
when
minus
you're
1.
saying
Okay.
this big O of n, this is the number of digits, right? When it is 5, you're taking a 5 level of space.
T of
Now
n.
tell me.
T of n minus 1.
Yeah, that's T of n minus 1 because at every step we are reducing the number of digits by 1.
Plus, is this fine? T of n minus, that's it?
Plus
Plus
constant.
C.
T of n
Plus
minus 1
C,
plus
plus C.
constants.
Plus constant C. Correct. So here, if you will be able to observe at every point of time, what you're trying to do, you're trying to reduce your number by one, by one, by one, by one, by one, by one, right? So it is T of n minus 1 plus constant C. It is similar to what we have discussed in a factorial of a given number. If you will observe, it's same actually. So if you will try to solve this recurrence relation by substitution method, what is the complexity? Big O of n. It's a linear time complexity task. You can try to solve it. You will be able to get similar way that we have discussed in factorial. You can refer the last session. So if you will be able to observe for this case, both the time as well as space is a linear time complexity task and space complexity task, where n indicates the number of digits that we have in a given number. Is this part is fine? Shall we move ahead to the next important part? Next important question, problem. One of the most interesting problem, and again, very, very widely asked problem in an interviews. Shall I move? So far, so good?
Yes. Yeah.
Next problem, problem number 3. Try to understand this problem pretty well. And then we will shift from collab to lead code, okay? Multiple problems can be solved with this problem. So please pay attention. We will spend a lot of time on this problem now, okay? Problem is very simple. You need to find out a power of any given number a to the power n. So what you need to compute is a to the power n. Simple. Okay? Where a is any constant number which is provided to you, and you need to find out what is the value of 2 key power. For example, let's say a key power a is 2, and let's say n is 8. So when I'm saying 2 key power 8, how basically we can solve this problem?
2 into 2 into 2 into 2, so on until 256.
Until 8 number of times. That's what
Yeah.
we usually do, right? So I can call it as 2 into 2 key
2
power
into
7.
2, 7. Yeah.
Then I can say 2 into 2 key power 6. Just
Mhm.
like the similar way we did to factorial question. Similarly, we can extend this also. Acha. If we do like this, in this manner, what is the base case condition and what is the recursive function called? Base case would be in the power case. Think over it.
So if n is equal to 0, then it is 1.
If n is equal to 0, correct? Then we can directly return the answer as
1.
1.
It's correct. It's a
If
base
n
case
is equal to
condition.
1 is equal to 2.
Yeah, that can also be, you can add. If you don't, if you want, you can add. If you don't want, that's also fine. If n is equal to 1, you can return directly a. That can also be set as a base case condition, where we are not doing anything, higher complexity task and directly returning the answer, right? Question is, let's pay only this as a base case condition as of now, and we'll avoid this as of now. You can add this also. I'm not saying that it's not be a base case. You can add. But let's say as of now, for the ease of explanation, I'm removing the second condition. If the value of n is bigger than 0, in that case, what is the recursive function call here? What is the recursive function called?
A raised to power n minus 1.
A times power of a into a comma n minus 1.
For example, here my function name is power of containing the parameter a comma n. So this is my base case condition. My recursive function call will be, can I say a into, again I'll call my function name again, power of a comma
n
n
minus
minus
1.
Correct? So basically, what we are saying here in this problem number 3, to find the power of an element, we are saying that, let's say, Our driver code. Okay, someone have already written it down. Okay, let me copy it directly then. So Pawan has shared me the code. I think it's very much apt. So I'm just copying it down. Here, if you will be able to observe, power is, I think we have predefined function in Python also, if I'm not wrong. No, we don't have. It's, I think for math.pow we have. Okay, then it's fine. So this is the function definition we have. Now, again, one important thing that if someone in the interview is asking you power finding and then you're using a predefined function, inbuilt function, it's not a correct way to approach the problem, okay? So this is the driver code. To keep power 8, we need to compute. So what he has done, this is the base case condition, right? That's what we have discussed. And this is something which we are saying is the recursive function call in the else part. Let's try to run this. Correct, right? 2 की power 56. If you will just add this as 10, you will be able to get accordingly the answer 1024. Makes sense, makes sense. But now in this case, if I'll ask you again, what is the time complexity of this approach? I hope implementation wise, it's quite easy. Anyone, any doubt? So far, so good, right? In terms of implementation, it's fine for everyone. Perfect. So now tell me, again, try to create a recurrence relation for the same and let me know, what do you think is the time and the space complexity required to implement this particular code? What is the time complexity? And what is the space complexity? First of all, let's talk about again space part. How much is the space requirement?
Order of n.
Very good. It's order of n. So again, you will use a stack space and you will observe that whatever be the value of n, that is the power term that you have, that many number of function calls you are doing when you're doing computation, almost. So that is equals to big O of n. Let's focus on the time part. What is the recurrence relation? When the value of n is, let's say you are saying equal to 0 or maybe less than 1 also, less than or equal to 1, you are saying the answer will be constant. Either it will be 0 or it will be a. It's a constant task. When the value of n is bigger than 1, what will be the recurrence relation?
Again, t of n minus 1 plus c.
Does everyone agrees with her? Think over it. See what you are doing here.
We are reducing the power by 1.
Very good. So here it will again remain the same because you are trying to reduce the power by 1 by 1 by 1 by 1 and constant task you are doing with respect to this multiplication kind of a thing with 2, right? So it will be nothing but is equals to t of n minus 1 plus further constant task. So overall it will be again a linear task. Linear task for both the time and the space part. Now the question is, this is the brute force approach. This is approach number 1 to solve this problem. Can we optimize this approach? And that's where a very important aspect of approach number 2 came into picture. There is something that we discuss in our upcoming sessions in the algorithm module called as divide and conquer. Divide and conquer algorithms. Basically, this power finding is an application of this particular approach only, divide and conquer. But today we'll discuss the demonstration of this particular example, and you will get a brief idea of this particular algorithm also, that what we are trying to do here. This is a strategy in the algorithm that we have, very famous. Even binary search that we have discussed is a part of the strategy. And today we are discussing power of 2, power of any number also is an application of this strategy. Okay. So let's try to discuss here. Basically, Let's say I will be having a number as A as 2 and N as 64. Very big number I'm taking. What we can do here is, we can divide our value of N into two parts. Dividing 2 ki power 64, 64 by 2 is 32. So what we can we write like this? 2 ki power 32 into 2 ki power 32? The same number 2 ki power 64.
Yes.
Now, what can be the base case condition? We have already defined the base case condition will be when maybe the value is 0. At that point of time, I'll return my answer as 1. So what we will do is, we will keep on splitting our data into two components until we reach that base case condition. So 2 ki power 32 will become 2 ki power 16 into 2 ki power 16. 2 ki power 16 will become 2 ki power
8
8.
and 8.
2 ki power 8. 2 ki
4,
power 8
4.
will become 2 ki power 4. 2 ki
2
power 4, right? After that, let's move ahead. 2 ki power
2,
4
2.
will become 2 ki power 2, 2 ki power 2. It will be 2 ki
1,
power
1.
1, 2 ki. I think we can stop it here itself, because again, it's also a base case condition. When the value of N is 1, directly return the answer as A. That's it. So basically what we have done is, this is a recursive tree that we have. In this recursive tree, what we have done is, we have tried our data of N into by 2, by 2, by 2, by 2, by 2, until we reach to a base case condition. And here we can return our answer directly as 2, which is the value of A. Now here, what I will do is, I'll not calculate separately the answer on the right side. Here I'll optimize my code. Why? Because I know on the right side, I will be having a similar answer, which I already have computed on the left side, right? So what I will do is, whatever answer I'm getting, I'll do the multiplication with the same answer to return the above answer, which is 4. I'll say 4 into 4, 16. 16 into 16, 256. 256 into 256, I think 65536. Just check it out. And then multiply these two numbers also. Just let me use the calculator. If anyone has, please do that. 256 into 256. Yes, I'm saying it correctly. And then if you multiply the same number, oh, I don't have a scientific calculator. Does anyone is having? What is the exact value we are getting? It would be very bigger value. It will be 65536 into 65536. Whatever value you will be able to get is the answer. Right? So basically what we are trying to do here is, we are trying to move ahead and we're trying to multiply the same value without doing a recalculation on the right side stuff. Is that thing is making sense to everyone? Is that thing is fine for everyone? Yes,
Yes.
whatever value we will be able to get, some bigger value we will see. Some bigger number we will be able to get. But is this logic is clear to everyone? Main thing, whatever be the calculation, I think that would be fine. I got some answers also, but it's okay. So basically what we have done, if I'll just try to write a pseudo code for the same, let's say I will be having a, again, function name as power of, having a value of a comma n. In this code, in this particular logic, what I have done, I have said if the value of n is 1, my base case condition, return a. Otherwise, do one thing. First of all, try to calculate the value of mid. We are dividing our data. What is that value? N divided by 2. Do the division first. This is called as division, dividing the data, dividing the problem into various sub-problems. After that, our result will be equal to what value? We will call this function again, power of a comma mid. We will do the same task with that mid value. That is the result. We are storing that result here. Let's say we will keep on doing this task, finding that mid value, mid value, mid value, until we reach to this condition. And initially my result will store this value of 2. When I'm going back, my final result will be nothing but is equal to whatever be the result value it is storing. For example, 2. I'm doing a multiplication with the same result to get my final result. Can I say, everyone?
Yes.
This is my final result, not this one. This is my final result. I'm doing this thing to avoid the recomputation on the right side. Now you can ask me one more question, that Priya, here you are doing very smartly n as 64, right? But it is nowhere mentioned that n will be always even number, n can be odd number. How will this approach be applicable? What you will do in that case? So I will say that, can't we use our brain and do like this? 2 ki power 65, let's say someone is saying, interviewer is saying that, try to compute this thing. You can say that I'll compute like this, 2 into 2
Subtract
ki
a
power
value.
60. And
Yeah.
I'll do the same logic here. Whatever things I have just now discussed, I'll implement this. So at any point of time, if my value of n is odd, the only difference is I have to multiply a one more time. That's it. So what I will do, I will make a check at the final end. I'll say, if let's say my value of n is even, at that point of time, so my final result is the final result. I'll simply return that final result. Otherwise, what I will do is, I will simply return a into whatever be the final result I'm getting. For example, in case of 2 ki power 65, I got final result in the 2 ki power 64 term. I'll multiply this with one more time into 2 to get the final answer. That's it. So at any point of time while splitting also, if any odd number will come up, it will make sure that it will handle that scenario as well. I'll let you know that how this approach is more efficient than the above one when we talk about the complexity aspect, but is the logic is clear as of now? So here we are doing a conquering part. This is calling the sub problem again. This is what we call as divide and conquer. When we are moving from top to down and then moving back, storing the values of final result, that is where you're doing a conquering part. Divide and conquer. Is this clear? Is the logic is clear to everyone?
Priya, can you just again explain the left side calculation you're doing, like 2 to the power 2 and 4, like this? Yeah.
Which one? Okay,
The
this
calculation.
left side thing.
Yeah, calculation. Yeah.
So basically what we are doing in this recursive tree, we are trying to split our data into the sub problems, dividing by 2, until we reach to a small problem or a base problem. This is what we call as a base case condition. Base case condition. So what I'm doing is I will keep on splitting my data points until I reach to this condition where my value of n will become 1. This is where I'll directly return my answer because I know anything to the power of 1 is a itself. So I'll return the answer as 2. Now what will happen when I will move back? So I'm not doing a recomputation of the right side because I know whatever value is available at the left side, the same value is also available at the right side. So what I will do, I'll take 2 into 2. So that's where I'm doing a multiplication of the same result 2 times to get the final result. Finally, once you will be go back 4 into 4, 16, 16 into 16, 256 and so on. You will go back to the 2 ki power 64 term. Now the question is that it's an even number. What if we will be able to get an odd number? In that case, just a one check more is required because the only difference, if let's say you will be having an odd number, what you will do, you will say 2 into 2 ki power 64. That will, if the values are same, you can add the powers. Base is same, add the powers. 2 ki power 65 only, right? So what you can do, in that case, you can just return a into final result. That's it. Is this clear now?
Yeah.
Will you guys try to implement this part? This pseudocode? Just try it out. Take this 2 ki power 64 only and see what number you're getting in your code. Correct? I got two responses, both are correct. I have already written it down. the pseudocode. Write it down, the code part. So basically what we are trying to do here, let's say the same thing, but we will change the implementation inside the power function. So what we are saying, what is the base case condition? If my value of n is equal to 1, I'll return A. Otherwise, what I will do? First of all, I'll try to divide my data into two components, n by 2. I'll try to find out the result, which is nothing but power function, A comma mid. My final result is not this result. My final result is the multiplication of the same number 2 times, left and right. Finally, I need to handle the odd and even case. So what I'll do is, I'll take a check. If my value of n is even or odd, so if n modulus 2 is equal to 0, it means it's even. If it's even, I'll directly return the final result. In the else part, what I will do is I'll return A into the final result. Done? Let's check this number first. It's a very small number. Coming correctly. Let's take 64 here. It's giving some bigger value. I don't know. Let's take some small number, 20, 10486, 16, 65536. So basically, this is the power thing which it is providing to me. And I believe it's correct. Is this fine? Is this logical part is fine to everyone? Now, if I'll ask you again the same part, what is the time and the space complexity for the same? Let's work on that part. And then we will see how it is better than the previous approach. So what is the recurrence relation? Anyone? Think over it. Base case condition is a constant thing. This is where we are doing a recursive function call, right? But before that, it's a middle finding. It's a constant task C. Recursive function call. What is the, recurrence relation for this part? Anyone who can give me the answer? Let's say our complexity is T of n. So in this recursive function, what will you tap upon?
n by 2.
Very good. Very good. Basically, what you are doing a division by 2, by 2, by 2, right? So can I say it will be T of n by 2? Yes or no? Again, computing this final result or checking the even and odd is again a constant task. So the simple meaning is what we can say, if the value of n is, let's say, less than equal to 1, it's a constant task. If it is bigger than 1, it will be T of n by 2 plus C. Can I say everyone? Constant, you can also write it as 1. Big O of 1 can be also written it as 1. Simple. Is this correct? Now try to solve this recurrence relation. T of n is equals to T of n by 2 plus C via substitution method. Do this and let me know what is the complexity you are getting. Apply substitution method here and give me the answer. In the last class, I have talked about how the substitution method will work? Can you give me the result? Anyone? Okay, I got the result from one student, which is very much apt. Very good. Can I get the response from others as well? So what we can do, we can try to compute this value of t of n by 2. What we can write in t of n by 2, it can be written as
T of n by 4 plus c.
t of n by 2 की power 2 plus c. Yes? So write in this equation, t of n is equals to t of n by 2 can be written as t of n by 2 की power 2 plus c is also there. So both together will form as 2c. Can I say everyone? Perfect. Now t of n by 2 की power 2 can be written as t of n by 2 की power 3 plus 3c. If you will keep on doing this task until k times, what is the kind of equation you will be able to get? Generalized equation. T of n is equals to
N by 2 to the power k.
plus
C.
k times c. Can I say?
Mhm.
Now, what is the best case scenario when the value will become 1? Because we know the value of t of 1 only, right? When the value of n is 1, at that point of time, it's a constant task. It's a c. So solve this. You will be able to get the answer as log of n base 2. Apply the value of k as log of n base 2 plus log of n base 2 into c. If you remember the property of log, I have discussed and I have mentioned that this n and 2 can be replaceable. You can put n below and 2 above. So if you can do so, you will be able to get that n by n की power log of 2 base 2 plus c times log of n base 2. This is 1. This is 1. T of 1 is constant. Constant plus constant time log of n base 2. Overall complexity will become log of n base 2. In general, you can also write it as log of n only. So in general words, it is nothing but is a logarithmic time complexity. Will you guys agree with me? It's a logarithmic time complexity. Yes, everyone? So in the approach number 1, we got a linear time complexity. In the approach number 2, we got a logarithmic time complexity. So which one is better?
Logarithmic.
Logarithmic. That's why approach 2 is far better than approach number 1. So if someone is asking you this question of power finding, you can start with that approach. If you will observe, both the approaches are using the concept of recursion only, right? In second approach also, we have utilized the concept of recursion, but this approach we have solved via divide and conquer strategy. And that's where we have got a optimized solution of logarithmic time complexity. So far, so good. Shall we move ahead? An extension of this problem. I have taken, I'm looking for a value of n which is bigger than, 1 or equal to 1. Like positive values I am encountering. What if I will encounter a negative value? So that's where our lead code problem came into picture. So I'm sharing the link with everyone in the chat window. I want everyone to open in their platform, in the system, this problem. Implement this, which calculates x raised to the power n. X is given, n is given. Same problem which you can see. But here, if you will be able to observe, they're taking a negative value also. For example, when the value of n is -2, what we're expecting is the answer is 0.25. So, utilizing the concept, optimized approach concept, give me the solution for this approach. What? There's a bit of change which is required in doing the implementation of this problem. How will you do?
If n equal to 0, then we set it to 1.
But if there is a negative value, how will you approach that thing?
Whatever else we have to find that power value, simply 1 by divided by the result.
Very
we
good. That's correct. Can you guys try at your platform and give me the result, the code part in my chat? Let's see how many of you will be able to submit this problem pretty well. Then we will discuss that how we can solve. I'm giving a 5 minutes of time that if anyone wants to go somewhere, they can also go, kind of a break, and then we can start. Okay? Take your time. Those who don't want a break, please continue solving this problem. You can share me in the chat window. Anyone who got the correct answer? Yes, anyone? No answer? Expecting at least 1-2 responses. Have you guys tried? Subhash, Shilpa, Roshan, Prashant, Pawan, Arjit, Darshan, Yashasvi. Anyone? Getting max depth exceeded. What about others? Shall I implement or should wait?
Can you please discuss once again the approach how to handle the negative cases?
Okay, so basically, if you will be able to observe, let's say we will be having some number, which is let's say -2. A is 2, N is -2. So what you usually write like this? You will say it will be nothing but 1 by 2 ki power 2. So what you can write in a code as a condition is that the value of N is less than 0. In that case, what you will do? The variable which they are taking is, I think, X, right? X and N. So X is this, N is this. So what you are saying, whatever be that number you have, that X will become nothing but 1 by X. And this value of N, take it negative of N. So it will become positive. That's what you have done. It will become positive now. And then you can simply call the function again. Whatever with the function you have, power of. With the same parameter, X comma N. That's it. So automatically, that same process will be started. So basically, what we can do here is, first of all, what is the base case condition again? The
When
value of N
equals
is
0, then return 1.
Yeah, minus 2002 power 31 to plus. So here they're taking the negative number plus positive number. It means 0 is also included. So we can take the two base case conditions. If the value of N is 0 and the 1. If it is 0, return the answer as 1, right? In elif case, if the value of N is 1, return the answer as, return the answer as X. It's correct. Now, let's move to the next important condition. The value of N is less than 0. So it can be either less than 0, it can be either 0, it can be 1, it can be more than 1. So we have to handle all the cases here. Because it is mentioned in the constraints, you can just check it out. What are the values they are qualifying? So if it is less than 0, right? In that case, what we're supposed to do? we're supposed to say that now x will become 1 by x, 1 upon x, because if the value is negative of 2, we will take it as 1 by 2, 1 by 2 ki power 2. N will become positive now. So how we can say it will, n is equals to negative of n. Negative, negative will become positive. And then what you can do, you can simply call it again, return self dot my power function. Inside this, you will pass down the updated value of x and n. Now else case condition will come where if the value of n is bigger than 1, in that case, what will happen? First step, to find the middle value, which is n divided by 2. Second step is to call the recursion to get that result, which is equals to what? Self dot my power x comma n. Now, my final result will become result into result. This is the thing which we have already done. Now, checking whether the number is even or odd. If the value of n modulus 2 is equal to 0, it means it's an even number. We can return what? Directly the final result. If this is not the case, in else case, what we can do? We can return n into final result. Not n, sorry, x into final result. Now it is correct, right? Let's try to run this code first. Runtime error. Is there any issue?
Yeah, we are getting recursion depth exceeded. Still.
Oh, we are using n. Why? Mid, right? It should be mid here. No one have noticed also? Now check. Let's try to submit now. This is what we have done, right? In our collab also, same thing. Now it is fine. By mistake, I have mentioned here n. If we have to mention n, then why we are doing this task? Make sense? Correct? Everyone?
Yes.
So if I'll ask you again, what is the complexity of this code? Will this small change will impact the complexity? This is the small change that we have done. Will that impact the complexity? Or it will remain the same?
It will remain the same.
Yes, it will remain the same, which is log of n. The space complexity. What will be the space complexity? I think we didn't talk about that yet. Yeah. So what is the space complexity of this particular code? What do you think? Let's talk about space complexity aspect as well. So what is the space complexity for the same? If let's say you will be having a number, power of 64. So how many levels you're going? 1, 2, 3, 4, 5, 6, 7. Approximately you can say equals to 8. So can I say it will be log of n base 2? Big O of? Because log of 2 की power, sorry, we will be having 64 value, n value 64, right? So if you will solve this, you will be able to get 2 की power 8. 8 will move ahead. Approximately you're getting the answer as 8. That means that many level space you're using, right? Will you guys agree with me on this part? This will be logarithmic space complexity. Because the stack space which we are using here is approximately equals to log of n base 2. Yes or no? Just check it out. How many number of stack level space you're using here? Is this clear? Or shall I explain more about this?
Can you go over it once?
Can I?
Yeah, can you go over it once more?
Okay.
The
So basically, let's say we will be having a function name as, what is the function name on the lead code? Let's take any function name, by the way, but let's say my power itself. So we will be having a function which is my power, where a value is 2, n value is suppose 64, the example that I have explained you guys. So what we are doing, we are splitting our data into two components. So we are calling the function call will happen my power 2, 32, right? Then again we are saying my power 2, 16, and you know that every function call is getting stored in the stack, right? Again, my power 2, 8. Again, my power 2, 4. Again, my power 2, 2. Again, my power 2, 1. And that's where your code will return the answer as 2 because it's a base case condition. So all these function calls starting from this part, my power MP I'm writing 2, 64, then MP 2, 32, then MP 2, 16, then MP 2, 8, then 2, 4, then 2, 2, and finally MP 2, 1 is stored here, right? So how many? That's where you will get the answer as 2 at this point of time. So how many stack space you're using? 1, 2, 3, 4, 5, 6, 7. Approximately, it is equals to 7, right? In this case. And if at any point of time, if any call will go until 0, so it can go until 8 as well. So 7 or 8 function calls you will use in the worst case scenario. Now, when the value of n is 64, you are using approximately 7 function calls. That's what we have seen here. 7 stack spaces are required. So how will you able to get this number as 7? If you will be able to see log of 64 base 2, it is approximately equal to 8. That's where you're getting this call. So always remember the space complexity in this case is not n, just like the way we have done in the previous questions. It is log of n. So you are taking a logarithmic of that power value n as the space, as the number of levels. So if you will solve this question with 64, log of 64 base 2, you will be able to get the answer as 8 approximately. 8 minus 1, right? Log of n minus 1. So overall complexity will become logarithmic. So that's why the space part is here, log of n. For the 64, we're using a 7 function calls. Let's say you will be having 16, 2 to the power 16. Then how many function calls will you use? How many stack space in worst case you will use? What will be the answer? It will be equals to? Any result can I get?
3.
When the value of n is 16 and
Three.
let's say a is 2, how many stack space level you will use? This much time is required.
Approximately 3.
Yes? Is it correct? 3 to 4, you can say. Right? 16, then 8, then 4, then 2. So you're calling power function 2, 16. Then you will call power function 2, 8. Then 2, 4. Then 2, 2. Right? Divide by 2, you are keep on doing. Then 2, 1. So that's where you will stop. So it will be approximately 4 to 5, not 3 to 4, 4 to 5. So again, it will be log of n base 2 plus 1. So approximately, always remember the stack space requirement is big O of log of n. Logarithmic space complexity is required with this computation. Is this clear now? Can I get some confirmation?
Yes.
It will be always minus plus 1. Why we are getting runtime error? My error is not resolved yet. It's okay, Yashasvi. I'll share you the code. You can just check it out. There might be some small issue which you are doing in your code. It will be resolved. Otherwise, you can just refer in the discussion form. I'll try to help you out, or any other student can also help you out. Is that fine? It will be resolved. Don't worry.
Yes.
Now, the very last part of today's session, and then we will wrap up the today's class. The third method. Until so far, we have talked two methods to solve recurrence relation. One is substitution, one is recursive tree. This method, Master's theorem, is the last method. So whatever recurrence relation you can solve via substitution method, same recurrence relation you can also solve via Master's theorem. Sometimes what happens, substitution method, as you can see, requires a lot of mathematical things, right? GP series are forming up, then we are solving that GP series. Sometimes you will observe AP series is coming up. Sometimes you are doing a computation of that substitution. Sometimes it's very complicated equation you're getting. And then it might be complicated for you if you're not good with the maths, right? That's where researchers or developers have designed some equations, some formula, and they said that if you will be able to not handle that substitution method pretty well, if your maths is not that much strong, you can refer this chart and try to get rid of that equations and directly refer that, okay, this is the complexity of your code, but under a given constraint. The constraint is that your recurrence relation should be always in this form: a t of n by b plus theta or big O. You can, theta is, I hope everyone knows now what is theta, what is big O, what is omega. So they're taking it in an average case form, n ki power k log ki power pn. If there is if your recurrence relation is of this form, then you can apply the Master's theorem, where the value of a is bigger than equals to 1, value of b is always bigger than 1 strictly, value of k is again bigger than equal to 0, and p is a real number. So basically, if you are having this kind of a recurrence relation, which can be easily solved in a substitution method as well, you can apply Master's theorem directly to get the solution correct. Okay. For example, this is the first example which you can refer. For example, you have write a code, you have written a code of recursion, and you got this kind of a recurrence relation. So again, if you will refer this equation with this standard equation, this is the standard equation, right? SE, standard equation. What is the value of A? And what is the value of B? What is the value of K? What is the value of P? Referring the chart. Can you tell me? It's a simple maths. Equate these two equations, the recurrence relation which we are solving, and the standard equations which they have given to us. And let me know, by comparing these two equations, what is the value of A? These four variables are important to know. Then you will be able to get the complexity very easily. What is the value of A, B, K, and P in this equation?
Value P will be
A
2.
equals to 2.
Very good. B is also 2. What is K?
0.
0. Anything to the
1.
power of 0 is only 1, right? So because we are not seeing any n term here, it will be 0. What is the value of P? Anything to the power of 0 is 1. So this is also 0, right? Because here only 1 is written. It's a constant thing. So out of these equations, case number 1, case number 2, case number 3, which case we are lying? Is our value of A is bigger than B ki power K, or equal to B ki power K, or less than B ki power K?
A greater than B ki power K.
It means we are lying in the case number 1, because value of A is 2, which is bigger than 2 ki power 0, which is 1. So directly we can write it down, the complexity as, in this case, it will be T of n, which is equals to theta or big O, anything you can mention, n into log of a base b. What is the value of log of a base b? Log of 2 base 2 is equals to 1 only, right? Can I say everyone? So the complexity will come out to be linear. So here you can observe that I have not done much trouble. I have not did any substitution. We have solved the same problem in substitution also few minutes back, if you remember. We're getting the equation like t n by 2 ki power 2, 2 ki power 3, 2 ki power 4. Then we are generalizing in the form of k. Then we're trying to compute the value of k. That's a logical explanation of getting the linear complexity. But experimentally, like if you can, have this particular chart with you, or by practice, if you will be able to learn these things, there is no as such logic is there here, right? Directly computing it directly, referring the chart and then getting the complexity. That's it. So this is specially designed so that the people who are still struggling in mathematical portion, they can directly refer this theorem and compute the complexity directly without any trouble. So this is where we directly got the answer as big O of n or theta of n. When you're saying theta of n, you can also write it in terms of big O as well as in terms of omega. I hope you know that pretty well. Similarly, let's try to focus on example number 2. The value of A is 8. The value of B is 2. What is the value of K in this equation? What is the value of K in this equation? What is the value of P in this equation?
K equals to 3.
K is equals to 3. The
And
value of
P
P is
equals-
0. Now, what is the case we are lying here? What is the case we are lying here?
Third case. No. Second
Again
case.
thing?
Second
Case, right? So A is equal to B ki power K in this case. 8 is equal to 2 ki power 3, which is 8. So in this case, check the value of P. Here we have 0. So is this 0 is bigger than -1? Equal to -1 or less than -1? 0 value
greater than -1.
greater than -1 means we are lying in the A part. What is the complexity? This is the complexity. So it is nothing but theta of n into, again, log of A base B. Try to compute here. Log of A base B. Log of 8 base 2. What is the answer? Solve this. By the way, it is power. This chart is not mentioning it correctly. I think this diagrammatically mistake is there. N ki power log of A base B, log ki power P plus 1 into N. Similarly, this is also N to the power. Okay? Don't get confused here. Everything, whatever is mentioned here, log A base B is in the form of a power. Okay? So if you will solve this, this number is nothing but log of 2 ki power 3, this is 3. So N cube. After that, what is the answer? Log ki power P plus 1. So log P plus 1 is 1 only into N. So this is the complexity of our this recurrence relation. T of N, 8T N by 2 plus N cube. What is the value of K and P in the standard equation? See, in the standard equation, usually what happened is they have mentioned like this form. N ki power, let's say you will be having this kind of a equation. So in this case, your value of K will become 2. Your value of P also become 2, right? When you're saying it is a constant, it means you are having a value of K and P both are 0 because anything to the power of 0 is 1. Similarly, for example, here you will understand it better. If I'll say in this equation, what is the value of A, B, K and P? Can anyone tell me? A is 2, B is 2. What is the value of K? What is the value of K?
1.
1. What is the value of P in this equation?
-2.
Very good. -2. So P indicates logarithmic term. If there is, let's say in any equation, there is no logarithmic term, always remember P will be 0. Similarly, if there is no N available in your equation, recurrence relation, K is also 0. But here it is available. So K is also having a power. is also having a power. So always remember, K indicates the power of nth term. Power of nth term. And T indicates the power of log term in the standard equation. Simple. And there are many recurrence relations where you will not have the nth term power and log term power. It means in those equations, the value of K and P will be 0. For example, example number 1, we just have seen. And there are many examples which we have done also in which K and P is 0. So here, again, try to see which case we are lying. B ki power K is 2 only. So again, we are lying into the case number 2. Now, in the case number 2, the value of P is -2. So out of A, B, C, which case we are lying? -2 is bigger than -1 or less than -1?
Less than -1.
Right? So what is the equation? What is the recurrence relation? What is the complexity? N to the power log of A base B. So just compute what is the power of log of A base B? It will be 1. Log of 2 base 2 is 1. So your time complexity directly will come out to be linear again. Because n to the power log of A base B, it is 1 only. So it's a linear. Is this clear? Everyone? So it's kind of a theorem which is already provided to us. And we can directly, by seeing the case number, utilizing the property and getting the answer. Make sure it's in the power. Don't get confused, right? This is the power. N to the power, N to the power. There is a shortcut to solve this problem by which I usually solve these things. I have figured it out when I solved multiple problems of similar type while giving and preparing for my GATE exam. You can also utilize this shortcut, but make sure that this trick is nowhere written, is nowhere in the standard books. In the standard books, this is the theorem, and this is how logically you have to solve anything. But I'm telling you from my part how basically I usually solve these things very easily, because remembering these things will be very tedious task, right? It's not something which we will be able to recall it at each and every point of time. Let's say today I learned also these things. After 1 year, if you will ask me, I won't be able to recall. That's something which is very important to understand, that when we're talking about substitution method, we're solving logically. So definitely I'll go for that method after 1 year, right? Although it's quite easy, but remembering these things is quite difficult, right? So if you have provided these equations, well and good. But if let's say this is not available, so this trick is not applicable in terms of logarithmic part. Normal equations, which 90% of the equations are in a recurrence relation. What you can do is, for example, you have an equation of T of n, which is equals to T of n by 2, for example, 2T n by 2 plus C, right? So what usually I do, I try to calculate, I split my data into 2 parts. This is my function, f of n, and this is one part of equation. I try to compute what is the value of n to the power log of A base B, where A is 2, in this case, B is also 2. And try to compare the value between f of n and this. So what is the value? N to the power log of 2 base 2 will come out to be 1. What is the value of f of n? C. Whichever part is having a higher complexity, listen to me, whichever part, left-hand side versus right-hand side, is having a higher complexity, that is the answer. That is your answer. For example, it is big O of n. Simple. This is the complexity. Let's say I will write one more equation, 2T n by 2 plus n in this case. If let's say you will be having both are equal. Now, if you will try to solve LHS, you will be able to get the answer as n to the power log of A base B. Your value of f of n is equal to n, right? This is f of n, the right-hand side part. If you will solve this, this is also n, this is also n. At any point of time when you get similar complexity, your answer will become whatever with the complexity you're getting, multiply with the log term. multiply with the log term. So it will be n log n. Are you getting my point, what I'm trying to convey here?
Yes.
So this is one of the way. For example, for the binary search, the recurrence relation will look like T of n by 2 plus C. So if you will try to solve the left-hand side and the right-hand side no need to solve, it's constant. Left-hand side, A is 1, B is 2. So what is the value of log of A base B? Log of 1 base 2. What is the answer? Log of 1. Yes.
0.
Yeah. So can I say it's a constant only? Both are constant numbers. So in this case, as I said, when the values are constant, whatever be the value you're getting into log of n, so it is nothing but is equals to big O of log of n. This is the complexity. This is the recurrence relation for merge sort. You will observe after some sessions when we will discuss this algorithm. So similarly, you can easily solve this problem without referring the conditions that I have mentioned just now. But this will be applicable if you will not having a logarithmic case in the f of n. If logarithmic is there, then p value will come into picture. At that point of time, you need to refer this chart only. But maximum situations you will be able to tackle via this part. This will work fine for maximum scenarios. Is this clear? This you can implement. Okay. Whenever no log term is available in f of n part. Otherwise, that is a standard algorithm which I just now talked about. Any doubts so far?